Hi everyone, this is Aashita from EduUdr. Welcome back to the new tutorial video on data structures and algorithms. Today, in this video, we are going to discuss some important topics like firstly, we will discuss the definition of data structure. Secondly, we will discuss why do we need data structures in our real life. Thirdly, we'll be discussing the advantages of data structures. And finally, we will go through some examples on data structures. Firstly, what is a data structure? In simple words, data structure is defined as storing, retrieving, and organizing the data such that it would be useful for us to perform some operations on that data in an efficient manner. Let us go through the textbook definition. It states that data structure can be defined as the group of data elements which provides an particular way of storing and organizing data in the computer so that it can be used efficiently. It states that data structures are defined as storing and organizing the data in a computer so that they are used efficiently. We have the second definition too. Data structure is a way of collecting and organizing data in such a way that we can perform operations on the data in an efficient way. As I said earlier, data structure is defined as storing, retrieving, and organizing the data such that we can perform some operations on that data in an efficient way. This is the definition of data structure. Now, coming here, why do we need data structures in our daily life? See, everyday applications are getting complex and amount of data is also increasing, right? Due to this, the following problems may arise like processor speed. To handle very large amount of data, we require high speed processors, right? Due to the huge increase in amount of data every day, processors may fail to deal with that huge amount of data. The second problem is the data search. See, if you have some 100 items in your store and if your application want to search an particular item, it needs to traverse all the 100 elements every time of search. This results in slow down of search process as it takes lot of time to search a particular element, right? So now coming to the third problem is multiple requests. See, if more number of users are requesting the data parallelly on web servers, obviously, in that process, there are lot of chances that a very huge server can be failed. So, in order to solve all these problems, data structures are used. Next, coming to the advantages of data structures. The first advantage is efficiency. Basically, efficiency is a program depends on the choice of data structures. See, for example, suppose we have some data and we need to perform a search operation for a particular record. In that case, the first data structure that comes into our mind is an array, right? If we organize the data in an array, we will have to search sequentially element by element. Hence, using array may not be very efficient here, right? Meanwhile, there are better data structures like ordered array, binary search tree, or hash tables. Next advantage is reusability. Here, data structures are reusable. That is, once we have implemented a particular data structure, we can use it in another place. And the next advantage is the abstraction. Basically, data structure is specified by the ADT. ADT, which means abstract data types, which provides a level of abstraction. In C++, we know what is abstraction. It is nothing but showing the required details by hiding the implementation details. In more detail, take a client who will never be getting into the implementation details. The client will be getting only into the interface, that is user interface. Suppose if you take a web application, the client will be accessed only the contents that are present in the web page, and the client will not be bothering about the frameworks, methods, the implementation code and such stuff, right? So these are the advantages of data structures. And now coming to the example in real world. Here I have taken two real examples, like two real world examples. They are dictionary and the other is database tables. Coming to dictionary, see, of course, we all know that there are many words in dictionary. Like, I don't know the count, as every time the new words have been added. Now, if you want to search the word computer in dictionary, what you do? You will go to the word C and then go to O, then M. So at last you will be able to find the word computer in the dictionary. But if suppose the words in dictionary are not organized in alphabetic order and I asked you to search the word, then of course it would take hours or days to search that word in that dictionary. So in the starting you are able to search the word because the words are in organized manner, right? Now coming to the database tables. See, the database tables may be of the informative tables of employees or the customers who buy the product or the customers who are requesting for the loan data. This table is of the employees database table. Here, everything is organized, right? In employee ID, IDs have been arranged, employee name, department ID, salary, department name, and the location of that department. See here, from this table, we can get salary details of a particular person with his or her employee ID. Next, we can find the average of the salaries. Like we are able to perform operations as they are organized, right? So these are the two real-time examples of data structures. And let us go to the example in programming. Let us consider an array data structure. Basically, an array is a linear data structure where it contains number of elements of same data type. See, Now let us look through the declaration of data for array data structure. See, now we are having integer as a data type and the variable as marks with array size of 6. Let us consider the marks of 6 students in a subject where the first student got 76, second student has 62, third student has 83, fourth student has 94, fifth student has 55, sixth student has 66. In this array, the address of each element is contiguous. See, it is contiguous, not continuous, where we look the random size. Suppose if the first element has 1000 as its address, then the next element will be 1004. As the data type is integer, as it take up 4 bytes. So that's why first 4 bytes are kept for the first element 76 and the next 4 bytes are kept for the second element 62 and so on till the sixth element will have 1020 as memory address. And next coming to the index numbers. An array in C++ starts with 0 number index and ends with n minus 1. Like if we have 6 elements, then the index number starts with 0 and ends with 5 as shown here. Now let's find the average of 6 student marks. Let us see a code to find the average of 6 student marks without using an array. See, we have created a variable of each student and add all of them and stored it in a variable. Now, we are coming to the code with array. See, the whole data is stored within a variable of array size 6. And by using for loop, we are adding up the marks and displaying the average of the marks. Now comparing the codes, we will say that the code without array is easy as we don't have for loops. But in terms of efficiency and performance, the code with array is the best code. See, every software company wants the candidate who are able to write the code efficiently. See here, smart work matters a lot than hard work. So that's all for the video. Thank you. If you liked the video, click on the like button. If you think it would be useful to share to your friends, kindly share it. And don't forget to subscribe to our channel. And the most important thing is to click on the bell icon so that you will not miss the upcoming tutorials on this course. See you in the next video. Until then, keep practicing the basics of C++. Bye bye.